To a lesson with Dr. Powell. Let's talk about the idea of work and what it means in a physics context. So, if we have force that's being applied over a particular distance, so this axis is going to represent distance, and this is going to be force, and this force could be variable and could be changing as we go over this distance. Um, then we're going to define the amount of work that's done. So let's just draw a little graph. So let's suppose at first we have, the force starts here, but then we increase the force, then we kind of back away maybe or something, and maybe we taper off and we stop pushing at that point. How much work has been done from this distance to that distance? Well, we're going to define the notion of work as simply being the area under the curve that we see here. Or in other words, the work itself from here to here can be thought of as an antiderivative of the force function with respect to distance. So we can think of it this way. If force, for instance, is in terms of newtons and distance is in terms of meters, so meters and newtons, then work, what units is it going to be in? Well, it's going to be in terms of, well, an area right here between newtons and meters, that's going to be newton meters. So we have work could be thought of in terms of newton meters. Or if this was or we could think of force and being in terms of pounds and distance in terms of feet, then you could think of work as also being pound feet. Okay, kind of like so it gives you a notion of how much work is done, kind of like force meters or force distance when we're going when we're actually having an effect. So an effect over a distance. So I mean, if a lot of force is being applied, but there's no distance that's traveled, then we say no work has been done. There's been a lot of force, but there's been no distance. This is kind of like effectual force through a distance. It's kind of the idea that we are measuring, but we're going to define work as being this. So you could think of it as an antiderivative of force with respect to distance. So if x represents distance, right, and let's say this force, this is f of x, so force function. So the work is going to be an antiderivative of that. So we could even say that the derivative of work with respect to distance is equal to force. So if the units of work are, for instance, newton meters, then a little change of work will have a unit of newton meters, and a little change of the distance will have meters. So you can think of this as either as being like this, canceling out, and so you get newtons as your units for force. Hopefully this helps a little bit in introducing the idea and notion for what we are talking about when we say work. So we're just taking work to be, from a definition, just the area under a force curve. So a force curve, and work is the area in there in such a way. Thanks for watching.